in this video we're going to describe what the slope of a word problem represents. So when talking about the slope of a word problem, slope is also called a rate of change. So if you hear someone discuss the rate of change in a problem, they're really talking about the slope of the line modeled by that situation. Now, here's a word problem down below, and it says the table shows the cost of using a computer at an internet cafe for a given amount of time. Find the rate of change in cost with respect to time. So here we can see that X is time and Y is cost. Something you should typically know about word problems is if you have a time variable, it is typically represented with X. And if you have a cost variable, it is typically represented with Y. So what we have in this table are a variety of points. This first point here is really the point X is 2, Y is 7. This second point here is really the point X is 4, Y is 14. And this third row here is really X is 6, Y is 21. So what we're going to do here is we're going to calculate the slope by utilizing these points. So here we have slope equals rate of change equals, and we're going to utilize the y2 minus y1 over x2 minus x1 equation. So here we need to start by calculating our slope, and to do that we need to start by identifying the points that we're going to utilize. So we need 2 points. I'm going to use the first 2 points because those numbers are a little bit smaller, and then I'm going to label them. So I have x1, y1, x2, y2. So now if I substitute these points in, I have y2, which represents 14, minus y1, which is 7, divided by x2, which is 4, minus x1, which is 2. So now if I simplify, I end up with 7 over 2. Now, the 7 over 2 really doesn't mean much unless we remember to include our unit. So this is where the rate of change really matters, because we need to include our units so that we can describe the rate of change, or the rate of how things change over time. So now if I think about my y variable represented cost in dollars. So that 7 really represents $7. And then the x variable is represented by hours. So this 2 really represents hours. So the rate of change over time, or the rate of how our cost changes, is that our cost increases $7 every 2 hours. So this is called our rate of change. It describes how the rate, or how the cost, changes over time. All right, so here we're going to look at a second word problem just so we can see a different rate of change. So this says a community theater performed a play each Saturday evening for 10 weeks. The graph shows the attendance for the performance in weeks 1, 4, 6, and 10. Describe the rates of change in attendance with respect to time. So we're going to focus on 3 different periods. First, we're going to focus on weeks 1 through 4. And remember, to find our slope, we need to use y2 minus y1 over x2 minus x1. So here we can see that we have the point 1, 124. So I'm going to label that x1, y1 for this first set. And here we have at the end of week 4, x2 and y2. So to calculate our slope, we're going to take y2, which is 232, and subtract y1, which is 124, all divided by x2, which is 4, minus x1, which is 1. So now if we simplify this, 232 minus 124 is 108, divided by 4 minus 1, which is 3. And then if we divide 108 by 3, which we can do evenly, we get 36 over 1. So now remember, because this is a rate of change, we need to actually think through what this actually represents. So remember, the 36 is related to the y values, and I can see my y values are the number of people. So what I can see here is I have 36 people, and then the x values are represented by weeks, so I have 1 week. So what this rate of change is really telling us is that attendance increased during these first couple weeks by 36 people per week. So that's what this is telling us. We went up by 36 people a week over those first 4 weeks. So now we're going to focus on this second piece here. So I'm going to erase my points over here. Now I'm going to focus on 2 different points for weeks 4 through 6. So here is week 4, so we're going to do x1, y1, and x2, y2. So here we're going to calculate slope again, just between 2 different points. So m is equal to y2, which is 204, minus y1, which is 232, divided by x2, which is 6, minus x1, which is 4. If we now simplify that, we get negative 28 divided by 2, which simplifies down to negative 14 over 1. And again, we want to think about units. So remember that our y coordinates, which are in our numerator, which is this negative 14, y is people. So this is saying minus 14 people. And our x coordinate is represented by weeks. So we have 1 week. So what this is really telling us is that over this particular time period, attendance decreased because it's a negative 14. So our attendance decreased by 14 people per week. So after an incline for the first 4 weeks in attendance, after week 4, the attendance started to decline. And now we're going to take a look at that final time frame. So again, we're going to erase some pieces out of here. And we're going to look at that last time frame from week 6 to week 10. So here we're going to label x1, y1, x2, y2. So we have m is equal to y2, which is 72, minus y1, which is 204, divided by x2, which is 10, minus x1, which is 6. So I start off by taking 72 minus 204, which is a negative 132, and then 10 minus 6 is 4. I then take negative 132 and divide that by 4, and I find that I get negative 33 over 1. Now remember, we want to utilize units here, so I know that my y-coordinate is people, which is in my numerator, and my x-coordinate is week. So what this is telling us here is that in this final region, these last 4 weeks of the performance, our attendance decreased by 32 people per week.